So as we know, a lot of the bacteria that we have in our gut, especially bacteria that are responsible for making what we know as small chain fatty acids, also make a very important small chain fatty acid known as butyrate. And in this module here, we will be talking about how butyrate has such an important function in being able to make sure that our gut lining is very safe from being exposed to any form of foreign proteins and toxins that can actually induce a state of hyperpermeability. And the way how this happens is by the following. So as we know, a lot of these bacteria that we have in our gut are represented by five main groups, which are the five biggest phylums. As we know, we have the Firmicutes and the Bacteroidetes, which represent basically approximately around 90% of all the bacteria that we have in our microbiome. Actinobacteria, and especially today we will be talking about a bacteria known as bifidobacteria, protobacteria, and verrucomicrobia, which is also represented by a species known as Akkermansia. So in other words, we will be talking about bifidobacteria and Akkermansia to a certain point, okay? But these are the main five phylums that we have in our microbiome. Now, we know that bifidobacteria is a bacteria that lives in our microbiota, and when we consume certain foods that are rich in fiber, one of the things that this bacteria does is that it converts it into a small chain fatty acid known as acetate. All right, now we know the most three abundant forms of small chain fatty acids are acetate, propionate, and butyrate. Right, so bifidobacteria makes acetate. It does not actually make butyrate, it actually makes acetate. And when acetate is made, this feeds a group of bacteria that belong to the phylum of Firmicutes, and here we can mention Faecobacterium prosnutzi, Roseburia, Eubacterium rectale, Butyrovibrio, Coprococcus. So we have a group of bacteria that are known to interact with acetate that comes from bifidobacteria through a process known as cross-feeding. Now, when cross-feeding takes place, these bacteria are going to eventually end up making, through a process known as fermentation, convert this acetate into butyrate through a process known as cross-feeding. Okay, now butyrate has many different functions, and one of the functions that it has is that it acts on many genes, and many of these genes are anti-inflammatory genes which act at the level of our DNA by inhibiting. We know that butyrate inhibits histone acetylase, so it promotes transcription and translation of many genes. And many of these genes that are upregulated are genes responsible for making interleukin 10, PPARY, and NFR2, which are very known for their anti-inflammatory properties. Okay, so one of the things that we also know that butyrate upregulates is when it acts upon the goblet cells, it's going to stimulate the production of mucin, right? All right, and we know that mucin is extremely important for our GI barrier. The more thicker our mucus layer is, the more we're going to be able to separate and isolate and reduce the amount of interaction that takes place between the microbiome from interacting directly with your immune system, right? Now, another thing that butyrate is really good for is because it also helps out whenever we have any old enterocytes or colonocytes that need to be renewed or regenerated. It takes it out of business and makes new ones show up again, right? So butyrate is very important for the replenishment of these cells that we have in our gut lining, okay? And also, let us not forget that also butyrate acts upon by expressing these two genes, which is known as BCL2 and caspases genes, which are very important for the prevention and occurrence of neoplastic cells that can be responsible for causing cancer. Okay. Now, all of these things are very important. And as we know, I did mention that Akkermansia is also very important because Akkermansia lives basically at the level of where mucin is found, because mucin is the food source for Akkermansia. Okay, so think about it now, right? If we don't have enough bifidobacteria, we won't have enough acetate. These bacteria will not be able to produce butyrate through cross-feeding, and hence we will not be making mucin. So in other words, if we do not have mucin in adequate amounts, Akkermansia all of a sudden now starts to reduce in numbers in populations, and eventually we end up losing Akkermansia. Now, a lot of patients, at least the patients that I see who do have autoimmunity, many of these have a lack of Akkermansia, and a lack of bifidobacteria. This just basically gives you a state in where these bacteria are depleted from the microbiome, causing a state of hyperpermeability. All right. In some instances, we might actually find Akkermansia increased, which is a compensatory effect, trying to make more of this mucin layer. It's trying to recycle the mucin layer, because that's one of the main functions of Akkermansia, is that it participates in the recycling of mucin. But through time, as this mucin layer starts to degrade and starts to thin out, Akkermansia gets compromised as well. And this is one of the reasons why we see that there is an excess growth of Akkermansia sometimes in these patients, because it's a compensatory effect. Akkermansia is trying to make more mucin in one way, because it also makes small chain fatty acids, but at the same time, it's a sign that you actually are compensating for the lack of another bacteria. Okay? Now, something that's fairly interesting is that a lot of people that I know and that I've seen taking vinegar, and we know that vinegar is rich in acetic acid. Now, this is something that's pretty interesting, because we know that these bacteria feed off acetate, correct, in order to be able to make butyrate. And interestingly is that vinegar, which is made of acetic acid, once it hits our stomach, right, and our stomach has hydrochloric acid, is going to break down this acetic acid and form what we know as acetate. And now here we have the small chain fatty acid that's necessary for our Firmicutes bacteria in order to be able to make butyrate. Okay, so this is why this form of taking vinegar in small amounts on a daily basis allows for the formation of acetate, which will feed your good bacteria that you have in your gut. Now, this does not mean that you don't need to be supplementing with any probiotics such as bifidobacteria. On the contrary, this is only a process, one step ahead, that you're just allowing for these good bacteria to be able to make that butyrate. But whenever you have a microbiome test that shows you that there is a lack of bifidobacteria or it is absence, then you need to start considering the fact that that patient needs to be on a probiotic. Now, sometimes, whenever you have extreme dysbiosis from absence sometimes of these other bacteria and in an overgrowth of other bad bacteria, well, it might not actually make the environment of the microbiome hospitable for bifidobacteria. So it doesn't even make sense giving a probiotic at that point. But if you start giving, let's say, inulin, which is a form of fiber that can actually allow for these bacteria to start to regrow again, and then perhaps down the road reintroduce a probiotic with bifidobacteria where there is an adequate terrain, the environment now has been changed, and it is more, I guess you could say, hospitable for the presence of bifidobacteria, then you might want to be able to consider the introduction of bifidobacteria as a probiotic. So one of the things I like to mention here is that the ketogenic diet, as we all know, is a diet that's low on carbohydrates. There's a certain amount of protein you also consume in your diet, right? And the interesting thing about the ketogenic diet is that it induces a state of ketosis. Now, when you have ketosis, one of the substances that one of the ketone bodies that are made by the liver is actually called hydroxybutyrate. And hydroxybutyrate is what actually feeds the brain and feeds our also intestines. So in a sense, if you're taking bifidobacteria, you are inducing a state of ketosis. It is kind of like if you were actually doing a ketogenic diet, because the ketogenic diet is anti-inflammatory. It induces the production of ketones, bodies which are going to nourish your brain. It's going to also cause a change in the microbiota diversity, because you are making hydroxybutyrate, which also is healthy for the production of mucus production, right, where we have our goblet cells. So in other words, whenever I have a patient who has an autoimmune disease, one of the things that I try to do is that I try to make sure that they're getting enough inulin, which is a form of fiber that comes from chicoria or chicory, and also introduce bifidobacteria in order for us to be able to have adequate amounts of butyrate. So the take home is that your microbiome is always trying to make sure that you have enough amounts of butyrate. And one of the things I've seen is that, and this has been also published in many different in many different journals, is that we have found that certain vaccines, such as the COVID-19 vaccines, can actually eliminate the presence of bifidobacteria from your gut. And this explains why we have so many cases of intestinal hyperpermeability and patients getting more prone to developing autoimmune diseases and what so forth. Okay, so I guess this basically wraps it up for the butyrate cycle. Thanks for listening.